Okay, writing an exponential function rule given a table of ordered pairs. The table of ordered pairs x comma y gives an exponential function. Write an equation for the function. Okay, so this problem is giving us a set of points that, according to the explanation, is an exponential function. We don't know that yet, but we want to find what is the exponential function that models this set of points. So here in Desmos, I have the set of points actually in green. These are the points that the problem gives me. This is optional. If you want to see how it looks, you can do this in Desmos. But I did that so that you see that I have a few points. And according to Desmos, this function should look like an exponential function. And as you remember, exponential functions may look like this. Okay? But we want to find the actual real function that fits these points. So, because it is an exponential function, I know that it's gonna be somewhat like this. Y equals a, which is a number, a constant that I don't know at the moment, times b, which is another number that I don't know either, to the x. To the x because it's an exponential function. So the problem here is that I don't know the value of a and I don't know the value of b. What I have to do is find those numbers. Find the numbers a and b, the right combination that makes this this function fits this set of points. I could do that visually in Desmos, for example. I can insert this expression here, and I have it in red. I have an exponential function here, y equals a times b to the x, and I have added two sliders, one for a and one for b, so that we can try to find the value by moving these sliders. If I move it, well, I don't move this to the left because if I do that, look, it won't go closer. I want to go to the right, maybe there. Well, it is not quite what I want. I'm gonna leave it here. 0.4 and b. Well, if I move b, oh no, I want to move it to the right, like that. It's getting closer to my points. Yeah, it's almost there, right? Yeah, like that maybe. That set of a and b looks very close to my function, but maybe if I have it there. So as you see, you can have a visual approximation, but it's very hard to find the actual values by doing this graphically. But I want you to see what we are doing. So we're looking for the values of a and b that make this function fits these points. If we want to find the exact values, we're gonna use it analytically. We're gonna use math to find those values. For that, first, we look at the set of points that we're given, and we see that we have an interesting value, and that is the value 0.1/3. We always want to find the values where we have zeros because that's gonna tell us more information about a function. I know that this is the value of x and this is the value of y. So I'm going to replace those points in my function in this one because I know that this function gives me this output at some point. So I'm gonna replace y with 1/3 equals a, which remember is a number that we don't know, v is the other number that we want to find, to the x, which in this case is 0. And I took this value because I know that anytime I have a number to the 0, that is going to be 1. That's why I chose that number. And by doing this, I know that 1/3 equals a times 1. And any number multiplied by 1 is the same number, so I get that. 1/3 equals 1, you see? By using math, I got the value of a. The only way for this function to match that graph that we have for Desmos is when a is 1/3. So I already know that the value of a is going to be 1/3, and I'm going to have it here. But I'm still missing the value of b, but now it's easier, right? Because I already know that my function is going to look something like y equals 1/3, which is a, I just found it, times b to the x. All right, now I only need to find the value of v. This is just an equation of one unknown value, which in this case is v. To solve this equation now, I can just take any point of the table that we are given any. I'm going to take, for example, 1, 3, and replace. This is x and this is y. So if I replace these 2 points into my function, I'm going to be left out with 3, which is y, equals 1/3 of b, which remember b is value we don't know, x, which in this case is 1. If I do the math here, I get 3 equals 1, 3 b. Well, any number to the 1 is the same number. There is not much math to do here. And now this is just a simple equation. If I want to leave my v alone, I have to move this 1/3 to the left side. And if this number here is multiplying my v, then if it wanna goes to the left, it's gonna be the inverse of that number. So that should be something like 3 times 3 equals v. And that is gonna be 9. So I know from this equation that my point, that the value of the b is 9. So I know the 2 values, 1/3 and 9. So my function, and I'm going to highlight it here, my function should be 1/3 of 9 to the x. That is a function that makes this. So if I go to Desmos and I try to find a 1/3 is 0.3, sort of, so 0.3 here, and b should be 9 here. Perfect, right? You see? By doing this mathematically, we can find the exact values that make this function, the red one, match perfectly with the points. And that is the answer to this exercise. Let's solve. And yeah, that it is y equals 1/3 of 9 to the x. Right.